Okay, so today we're going to look at why we would use a 13 Newton thermal block in Ireland. What we're seeing coming into the office is quite a few incorrect specifications for 13 Newton thermal blocks. Incorrectly specified in that they're specified in locations where firstly they may not be suitable and secondly they may not be required. So we're going to look into that in more detail later on. There's two reasons why 13 Newton blocks specifically, or 13 Newton thermal blocks, would be specified. The first reason is obviously structural. If there's a building, a high-rise building or a commercial building with high loading, obviously if the design team dictates that the block needs to be 13 Newton for structural reasons, then that's what it needs to be, so it has to be a 13 Newton block. But the second reason why 13 Newton blocks are often specified is down to durability. Blocks with higher strength have higher cement content and are deemed more durable. So if we look at stronger blocks, typically a standard block strength is 7.5 Newton, so a 13 Newton block is more durable because of the higher cement content. So we're going to look today at locations where they are used. We're going to differentiate between where a 13 Newton dense concrete block can be used and where a 13 Newton lightweight aggregate or thermal block should not be used, and what's the solution in those locations. So looking at NSAI standard recommendation 325, this is the recommendation for design of masonry structures in Ireland to Eurocode 6. And table 14 of this document, durability of masonry and finished construction, section A covers work at or below finished ground level. So if we look at the table here, we can see that it's set out into various sections. On the left hand side we can see a number of exposure classes, A1 down to A3, with A1 being low risk of saturation without freezing, right up to the most severe exposure, high saturation with high risk of freezing. Then if we look at the columns, the fourth column over there covers aggregate concrete blocks. So if we look at the data in the table, if we're using blocks in condition A1, we can see there that the requirement for that block, it has to have a minimum density of 1500 kgs per cubic metre. It has to be manufactured with dense aggregates conforming with the relevant standards and recommendations, and it has to have a minimum mean compressive strength of 7.5 newtons per millimetre square, which is typically what our standard dense concrete blocks achieve today. If we look to A2, the requirement for that block is the same as A1, but it uses a slightly stronger mortar. If we move on then to exposure A3, high saturation with a high risk of freezing. This is where the confusion is coming in, because the requirements are the same as A1. The block needs to have a density of 1500 kgs per cubic metre. It needs to be manufactured using dense aggregates, but it also needs to be 13 Newton in strength. And this is where the confusion lies. So it is a requirement for a 13 Newton block in this scenario, which has generated the confusion and incorrect specification around these 13 Newton blocks. There is currently no thermal block available in Ireland which meets these three requirements. There certainly is a 13 Newton thermal block available, but it doesn't have a density of 1500 kgs per cubic metre, and it's not manufactured using dense aggregates. So we need to be careful here when we're specifying this type of block. In the remarks section of table 14, it identifies the most vulnerable location, or where exposure class MX3.2 is likely to be located. So we look at the little diagram here, we can see we've marked up an area 150 millimetres above and below external ground level, and is at this location where the block is most vulnerable. It's likely to become very wet and stay very wet for long periods. So it's at this location really that table 14 is telling us that the block needs to be 13 Newton in strength, it needs to have the correct density of greater than 1500 kgs per cubic metre, and it has to be manufactured using dense aggregates. And when we're using a dense concrete block which meets these requirements, certainly there's no issue here. But if we're looking at a thermal block, the 13 Newton thermal block doesn't meet all these requirements, so it is not suitable. What's the solution then? If we need a thermal block for this location or for thermal bridging, and the 13 Newton thermal blocks on the market are not suitable, where do we go? What's the solution? Aircrete thermal blocks are the solution, manufactured by Mannok. And there's two reasons why Mannok Aircrete blocks are suitable to overcome this problem. The first thing, they're suitable because they do have a higher durability than dense concrete blocks, and they're durable enough in any of those locations. And the second thing is, if we look at the location where aircrete blocks are required, then they're not actually exposed to exposure class MX3.2. And we're going to just look at a few of those situations now. So why are aircrete blocks more durable, or why are they deemed suitable? There is currently a recognised freeze-thaw test method available for aircrete blocks, and this is unfortunately not the case yet for dense blocks or lightweight aggregate blocks. So and all Mannok Aircrete blocks have been tested and certified as suitable for use up to and including ground condition MX3.2. Also, EN 1996 Part 2, which is the specification of masonry for durability, which we're looking at here. Table B1 of that standard clearly shows that autoclaved aerated masonry units, which are Mannok Aircrete blocks, any of those with a density greater than 400 kgs per cubic metre is suitable up to and including exposure class MX3.2, and all Mannok Aircrete blocks have a density greater than 400 kg, so there's no issue with using them in any of those locations. The second reason why Mannok Aircrete blocks are suitable at this junction is if we look at the location where Mannok Aircrete blocks are typically specified. One block there on the bottom of the inner leaf at the same level as the floor insulation, providing continuity of insulation through the junction. That block is located such that there's a very low risk of saturation. There's limited risk of freezing, so there's no concerns around durability. So there is no requirement for a 13 Newton block of any kind at that location. So Mannok Aircrete blocks are more than suitable. If we look at the alternative thermal blocks on the market, if we're looking at, for example, lightweight aggregate blocks, which are a poorer performing product than aircrete blocks, you actually need more blocks at the junction to give the same thermal performance or the same psi value across that junction. So this typically is a detail where we see lightweight aggregate blocks being specified. And as you can see there clearly, there is a block located there at that location where exposure class MX3.2 is deemed to be present at that location 150 mil above and below finished ground level. So that particular block there needs to be 13 Newton in strength, but it also needs to be 1500 kgs per cubic metre, and it has to be manufactured with dense aggregates, or it has to be proven as freeze-thaw resistant. But at the moment there is no thermal block on the market in Ireland that meets all those requirements. So our only solution or option here is the Mannok Aircrete block. If we look at this particular detail, it's often used where it's a situation where Mannok Aircrete blocks may be located at that exposure class MX3.2, where our large foundation blocks are used as dead build from the concrete foundation up for speed of build. and there's no, the blocks are located in that vulnerable location, but because they are freeze-thaw resistant and because they're allowable as per ISEN 996 Part 2, there's certainly no issue using them in this location in this detail. So just in summary then, there is no thermal block available in Ireland to meet the requirements of Table 14 of SR 325. 13 Newton lightweight aggregate blocks are being unfortunately incorrectly specified for the reasons that we've mentioned earlier, and hopefully I've covered them in some detail. Unless for structural reasons, aircrete thermal blocks do not need to be 13 Newton to meet durability requirements. Mannok 7.5 Newton aircrete block is more than sufficient unless for structural reasons. Aircrete blocks are tested and deemed suitable for use in the most vulnerable locations up to and including MX 3.2, which we have covered, and also which we have covered ISEN 1996 Part 2 clearly identifies that aircrete blocks are suitable for use up to and including ground condition MX 3.2. So hopefully that clears up that little bit of confusion. Thank you.